All right, let's talk about one of the biggest buzzwords out there, blockchain. We're going to cut through all the noise and break down exactly what it is, and more importantly, how it actually works. And we'll do it using one simple idea that'll make it all click. Let's dive in. Okay, so to really get this, we have to start with the why, the big question. In our world, we trust companies, right? We trust a bank to say how much money is in our account. But what if there was no bank? How could you trust a digital record, a piece of data, without some big companies sitting in the middle calling the shots? That's the problem we're trying to solve here.
Here's the best way I've found to wrap your head around blockchain. Forget the tech, forget the jargon, just for a second. I want you to picture a magical, shared public notebook. That's it. If you can keep this image in your mind, everything else is going to make perfect sense.
So what's so magical about this notebook? Well, first off, it's a shared ledger, basically a public record book that everyone can see. It's also distributed, meaning thousands of identical copies are spread out all over the world on different computers. The rules of the notebook? They're enforced by software, by code, not by some CEO. And here's the kicker. It's tamper-resistant, making it incredibly difficult to secretly go back and change something that's already been written down. Okay, we've got our special notebook. So what do we actually write in it? This brings us to the three building blocks of the whole system: transactions, blocks, and of course, the chain itself.
So every single line item written in our notebook is called a transaction. You can just think of it as an instruction, like send $10 from my account to your account. But, and this is super important, it's not just a claim. It's verified by cryptographic proof. The system doesn't trust you. It trusts the math that proves you are who you say you are, and that you actually authorize that payment.
Now, obviously, writing down every single transaction one by one would be a total mess and really slow. So what the system does is it groups a whole bunch of these verified transactions together into a batch. This batch is called a block. The easiest way to think about it, a block is just one page in our shared notebook. And this is where the name comes from. It's so simple, you might even laugh. These pages, these blocks, are added to the notebook one after the other in chronological order. They form a chain of blocks. Literally, a blockchain. See? Told you it was simple. But wait a minute, if everyone has a copy of this notebook, what stops me from going back a few pages and, editing an entry to say my friend gave me $1 million? This is where the real magic comes in, the notebook security system. It's a concept called hashing. So what on earth is a hash? Don't let the word scare you. A hash is just a fancy term for a unique digital fingerprint. You can take any piece of digital information, a single word, a whole book, or an entire block of transactions, and an algorithm will spit out a unique string of characters. That's its fingerprint. Now, this fingerprint has two properties that are like superpowers. First, if you put the same data in, you will always get the exact same fingerprint out, every single time. But second, and this is the wild part, if you change just one tiny thing in the input, even a single letter from a T to a T, the fingerprint that comes out is completely different, totally unrecognizable. So here's how that secures our notebook. Each block, each page, contains the unique fingerprint of the block that came right before it. It's like a cryptographic seal. So if a cheater goes back and tries to change a transaction on, say, page 50, the fingerprint for page 50 instantly changes. That breaks the seal connecting it to page 51, because page 51 is expecting the old fingerprint. It's a domino effect that breaks the entire rest of the chain, and all those thousands of computers see it happen instantly. And what this all boils down to is a system that is super easy for anyone to check and verify. You just check the fingerprints, but ridiculously hard and obvious to cheat or to fake. This is a complete game changer for creating trust online. Now, you'll hear people throw around the word immutable, like things are written in stone by the gods or something. But let's be real, it doesn't mean it's magically impossible to change. What it really means is that it's just so computationally difficult and so economically expensive to try and change a past record that on a big network, it's practically impossible. So, the notebook is secure, we get that. But how do you actually prove that you own the stuff written in it? How do you control your funds without a bank ID? Well, that all comes down to your digital identity, which is made up of two things, a public key and a private key. Think of it like your email. Your public key, or your address, is like your email address. You can share it with anyone, no problem. That's how people send you stuff. But your private key? That's your password. It's the one thing that proves you're the real owner. You would never share your password with anyone, right? Same thing here.
It's your secret, and it's what lets you sign and approve transactions. And this leads to maybe the single most important thing to understand if you ever use this tech. When you control your own keys, you are your own bank. That means there's no customer service to call. There is no "I forgot my password" button. If you lose your private key, you lose access to your funds. Period. It's a huge amount of power, but it comes with a huge amount of responsibility.
So how do you not mess this up? Well, there's a master backup. It's called a seed phrase. When you set up a wallet, it'll give you a list of 12 or 24 random words. This phrase is the master key to everything. It can restore all your private keys if your phone breaks or you lose your computer. It is your ultimate backup. You have to write it down and keep it safe, and critically, keep it offline where nobody can find it.
All right, another thing you might have noticed if you've ever used this stuff is it's not always instant like a credit card swipe. So why do you sometimes have to wait for a transaction to go through? The answer is all about confirmations and what we call finality. When you send your transaction, it first has to get picked up and included in a new block, written on a new page in our notebook. When that happens, you have one confirmation. And every time a new block, a new page gets added on top of that one, your confirmation count goes up. It's like adding more and more security seals.
So having one confirmation means, hey, you're in the book. Your transaction is officially part of the record. For something small like buying a coffee, that's probably good enough. You can see it's there and you can move on. But for a really large or important transaction, you're going to want to wait for more. Once your transaction is buried under several new blocks, say 6 or more, it's considered secure and final. The amount of work and cost it would take to go back and try to change that one entry buried so deep under all those new pages, it's just astronomically high.
So let's just quickly nail down the big takeaways here. 1. Blockchain is just a shared, tamper-resistant notebook. 2. The security comes from hashing, those digital fingerprints that make tampering obvious. 3. Your private key is everything. It's your proof of ownership, so you've got to guard it. And 4, the more confirmations a transaction has, the more secure and irreversible it is.
And that really brings us to the most exciting part. We've just described a system for keeping records that anyone can check, but almost no one can cheat, all without a central company in charge. The first big idea was a new form of money. But I'll need you with this question. What else could you build with a system that has those properties? What other problems